Hello everyone. Okay, this is going to be the first of the two videos to review topic 13 for your math test. What I'm going to do is this video is going to be reviewing topic 13 reteaching in your math book. And then tomorrow I will post a video reviewing topic 13, the practice test. On Thursday, you'll be able to take your math test on Pearson Realize. And so this is your time to ask me questions of anything that you're not sure about, or to ask a parent for anything that you need help with. So what I'm going to do is I'm going to have the video camera on my laptop, but I'm also going to actually pull up our topic 13 reteaching. So if you see me looking at something, I'm just looking at my computer screen at the questions. That way I can help you with them. Okay, so if you don't have your topic 13 book or your topic 13 reteaching, please go get your math book out of wherever you're keeping it. And please turn to pages 723 and 724. Now, if you have not done these pages yet, please pause me and go do them. That way you can correct it as we go, and that will give you some insight on knowing like what you're having trouble with and what you're not. So if we look at set A for everyone that is done and ready. All right. Okay. So on page 723, we have set A, and it says two fractions are equivalent if they name the same part of a whole. What is one fraction that is equivalent to 6/8? You can use fraction strips to find equivalent fractions. So if we look at set A, they've given us any fraction strips that we need. So if you have your fraction strips in your homework folder, sorry, let me just move my laptop just a little bit. If you have your fraction strips in your folder, you can go grab those, but you technically don't need them because they will give you the picture of the fraction strips that you'll need for each specific problem if you need one. So if you look at the picture there, we can see that the red rectangle is equal to one whole in this instance. It's always important to know the size of the whole because we can't compare fractions as easily if I'm talking about a whole that's this big and you're talking about a whole that's this big, right? That would just be two different things that we're comparing. Now, if you look underneath it, we can see that there are blue rectangles that are labeled with 1/8 in each piece. So that's its unit fraction, 1/8. So if the unit fraction is 1/8, we know from topic 12 that that means that there are 8 pieces that will equal a whole. Well, because we're comparing 6/8, they didn't even put all 8 pieces. They only put 6 because we know that if we have 6 pieces of 1/8, that equals 6/8. So you can even take your finger, right, onto the screen or onto your book, wherever you're looking at it, and you're counting 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. So we know that's 6/8. We then have to figure out where we would line up pieces that are 1/4 and then count them to see how many we would use, and that will give us our equivalent fraction. So we can see that they have our yellow 1/4 strips, and we can see that there are 1, 2, 3 of them. Okay, so when we count them, we know we count 1/4, 2/4, 3/4. And so they've written 6/8 equals 3/4. Now, if you remember, equivalent fractions means different names for the same fraction. So the same way that I'm Miss Flores, right? That's my one name, but my other names are Shatra or Mom or Aunt Shatra, and all of those are for the same person, right? I'm the same person. I don't change. It's just a different name, okay? So 6/8 is the same fraction as 3/4. It just is going by a different name. Now, they also said you can use an area model, right, where we shade in the shape to see that 6/8 and 3/4 are equivalent fractions. This is what we did on our quiz before we left school. The fractions shaded below show the same part of the whole. So we can see the purple part is showing us 8s because the rectangle is divided into 8 skinny rectangles going across, right? And they have shaded in 6 because they're showing 6/8. Okay. Then if we look at the other one, there are 4 rectangle shapes, okay? And four parts that have been chopped out of the big rectangle. And there are 4 of them, and 3 of them are shaded blue, okay? So that's because they are showing us that 3/4 is the same as 6/8. Now, one thing that's important to notice is that both of those rectangles are the same size, because remember, if we're comparing, at least in 3rd grade, we're comparing things that are the same whole, okay? When you get a little older, you'll compare things that are coming out of a different hole. Okay, so we can see that when we look at the 2 shapes, right, that the purple and the blue line up at the same place. Even though this has 6 little skinny rectangles and this has 3 thicker rectangles, they meet at the same place. And that shows us that all of this is the same fraction of the total shape. So that's just another way of showing that 6/8 is the same as 3/4. So they are equivalent. So their directions were to remember that both sets of strips are the same length. So the whole is the same. Now, number 1, they want us to find what 4/6 is equivalent to. So we can see that there are 4 green boxes. Each one is 1/6. So if we count it across, 1/6, 2/6, 3/6, 4/6. We can then look, they drew 1/3 fraction strips for us. Well, we know something's equivalent, right? When they come to the same point, right, at the end. So they're going across and they stop at the same place. So when we take our finger and move it across, we see 4 of the 1/6, and then we go down to see, how many of the 1/3 pieces. And because there are 2, we can say 1/3, 2/3. So the answer to number 1 is 2/3, or 2/3. 4/6 is equal to 2/3. Now remember, if you're not sure if that's the correct answer, you can always use multiplication. Equal actions equals fractions, right? Equal action gives you equal fractions. In other words, what we do to the top, we have to do to the bottom. So if we are trying to figure out how to get from 6 to 3, we can figure out that 6 divided by 2 equals 3. So what we did to the bottom, we have to do to the top. So if they're saying how many of the thirds, we can say 4 divided by 2 equals 2. So 2 of the 2/3 pieces equal 4/6. If you're more comfortable using equal action, equal fraction, or if you're more comfortable with using the fraction strips, that's completely up to you. It is sometimes nice to have a way to check your answer, and that would be a good strategy. Okay, so for number 2, we have, this is the example with the area model where they've shaded in things. So on the left-hand side, we have a shape that has 6 rectangles in it, and 2 of them are shaded. So that's giving us the 2/6 that they already gave us. Now they're asking us what's equivalent to that. Well, let's look at the blue one. They've divided it into 3 pieces. So what should our denominator be? It should be 3. We then need to figure out what the numerator should be. Well, they already colored it in for us, so we just have to count how many pieces are colored, and the answer is 1. So our answer is 2/6 is equal to 1/3. 1 on the top, 3 on the bottom. Now, if you want to check it with your equal action, equal fraction, we can say, all right, 6 divided by what is 3? And we know the answer is 2. So 6 divided by 2 is 3. So in order to figure out what goes on the top, we would do 2 divided by 2, and we know the answer to that is 1. So number 2 is 2/6 equals 1/3. If you have any questions, jot a little note down on a piece of paper or in your book, and you can let me know on Classcraft or email me or ask a family member to help you. Okay, set B says, Riley says the library is 2/8 of a mile from their house. Sydney says it is 1/4 of a mile. So what they did was they drew one number line and divided it into 1/8 chunks, right? And they drew one number line and divided it into 1/4 chunks. Now, this is really important. The zeros are on the same place, right? The zeros line up and the ones line up. So the whole is the same on the top and the bottom, okay? It's just the little pieces in between that got chunked differently. And if we look to see where 2/8 is, and we circle it, okay, and then we look to find where 1/4 is, and we circle it, we can see that they line up together. So therefore, we know that 2/8 is the same thing as 1/4 because they line up on the number line. So now they want us to try it. So it says, in 1 and 2, write two fractions that name the same location on the number line. So if we're starting on the top number line, okay, we see 0 and 1, and then we see 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. What comes next? Okay, well, since we know normally 0 goes here and 1 goes here, that is 1. But you could also write 8/8 because they want us to write a fraction, okay? So if you wrote 1, it's correct, except that they asked us for a fraction. So you want to just right next to it, write 8/8. Well, then we know that we have to find out what equivalent fraction has the same location on the number line. Now, there are a lot of things that are equivalent. It kind of depends on what you drew or what you wrote. It didn't say that you had to write a number line. It just asked for an equivalent fraction. So we know that when the number on the top and the number on the bottom are the same, that it means 1 whole. So if 8/8 is their example of 1 whole, we just have to choose 2 more numbers that are the same on the top and the bottom. So you could have wrote 4/4. You could have wrote 5/5, 10/10, 20/20, 3/3, 2/2. It doesn't matter. As long as the number on the top and the number on the bottom are the same, it's equal to 1 whole. So the answer that I had thought of right away, because 8 and 4 are related, is I thought of 4/4. But there are a lot of other answers that could have been correct. For number 2, okay, so we have 0 on this end, and we know that normally 1 would go on this end, but they have 6/6 here, showing that that's the same thing as 1. So we have 0, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So your top box answer should be 3/6 because it comes between 2/6 and 5/6. I'm sorry. 2/6 and 4/6. So we know that 3/6 goes in the middle. We now have to find something that is equivalent, okay, to the number that is in the middle, which we already figured out is 3/6. Now, we know that there is a special fraction, that's a benchmark fraction, that falls between 0 and 1. The answer, okay, is in the middle. So what fraction goes in the middle? The easiest one to write probably would have been 1/2. 1/2. Anytime the fraction falls exactly in the middle, we know that fraction is 1/2. So 1/2 is the fraction I would have written, but as long as your fraction is equivalent to 3/6, it's fine. If you wrote 4/8, if you wrote 6/12, if you wrote 5/10, if you wrote 2/4, any of those would be correct, okay? So if you're not sure, you can ask a grown-up or you can send me a message on Classcraft and I will help you. If you had any questions on using the number lines to compare, okay, jot down a little note and that way an adult can help you in a few minutes. All right, we're going to move on to page 724. So now we're looking at set C. And it says you can use fraction strips to compare fractions with the same denominator. So they want us to compare 3/4 to 2/4. And again, remember, we're comparing the same size whole. So we're not talking about a small pizza and a large pizza. We're talking about a small pizza and a small pizza. So the denominator of each fraction is 4. 3 of the 1/4 fraction strips shows 3/4, right? 1/4, 2/4, 3/4. 2 1/4 fraction strips shows 2/4, 1/4, 2/4. The fraction strips showing 3/4 have one more unit fraction than the strips showing 2/4. So 3/4 is greater than, right? Alligator eats the big number, 2/4. All right. I'd rather have 3 pieces of the pizza than 2 pieces. Okay. Especially if I'm really hungry. So now when we're looking to do it ourselves, we need to remember that if the fractions have the same denominator, in this case 4, right? 3 over 4 and 2 over 4, then the greater fraction has the greater numerator. I'd rather have 3 pieces of the cake than 2 pieces of the cake, unless I don't like cake. So, number 1 says, compare 3/6 and 5/6. So, let's think about this for a second. Would I rather have 3 chunks of something yummy or 5 chunks of something yummy? Which one is going to make me happier, right? Which one's going to be more? I'm going to be happier with the 5 chunks because that is more of the cake or the pizza or the box of donuts that I get to keep for myself. So 3/6 is less than 5/6. In other words, the big side of your symbol needs to be eating the 5/6. Okay? All right, number 2. 4/6 something, 5/6. Well, let's think about this. Would you get more if you had 4 pieces, or would you want more or have more if you got 5 pieces? Well, let's think about that. Excuse me. So, if I'm having 4 pieces of something, like cake, and I'm having 5 pieces of something, like cake, I would get more if I got 5 pieces than if I got 4. So if I got 5 pieces and Lucas got 4 pieces, I would get more. So in other words, 4/6 is less than 5/6. So in this case, the alligator mouth needs to open up towards the 5 over 6, okay? Number 3, 5/8 something, 3/8. Well, I can either get 5 pieces or I can get 3 pieces. Which one is more? 5 pieces. So 5/8 is greater than 3/8. The alligator needs to eat the 5 over 8. We're done with set C. So if you had any difficulty with that, please jot a little note down that you need help from an adult, and then you can ask me or a family member later. Okay, let's look at set D. Set D says you can use fraction strips to compare fractions with the same numerator. So now we need to change what we were thinking about and look at the numerator, which is the number on the top, instead of the same denominator like in set C. And remember, denominator down, numerator top. So we're going to compare 1/6 to 1/2. Okay, so if we look at the fraction strips, it's obviously easier if there are fraction strips, but you won't always have fraction strips with you. So we can see that the numerator of each one is 1. So they're both a unit fraction. I'm getting either 1 piece of this or I'm getting 1 piece of this. The difference is in the size of the pieces. The whole is the same, right? Maybe I have a small pizza and a small pizza, okay? But this pizza is divided into 6 slices. So I'm sharing it with 5 other friends plus me. This pizza over here is only in 2 slices. So I have a small pizza with 2 slices, and I get one of those, and maybe Miss Vonberg gets the other one. So now we need to think which one is bigger, right? Am I going to get a bigger slice if I'm sharing with 6 people, or am I going to get a bigger slice if I'm just sharing and there are 2 people? Okay, myself and Miss Vonberg. Well, I love pizza, and so does Miss Vonberg, so we would rather have the 1/2. She gets 1/2, I get 1/2, and both of our pieces are big. If I'm sharing with 5 other friends, okay, if I'm sharing with Miss Vonberg and Teo and Liam and Amelia and Tahira and Lauren, now we have so many people sharing that my slice is going to be much smaller. Just like if the whole class was sharing a small pizza, our size of our slices would be so skinny. But if I was only sharing with, let's see, Kylie, right, our pieces would be very big. So let's look at the examples that they want us to see for ourselves. So we're on set D. Number 1, they have 3/4 blank 3/8. So I have to think to myself, either way, I'm getting 3 pieces. I'm either getting 3 pieces of this cake or I'm getting 3 pieces of this cake, okay? The first cake, 3/4, I'm sharing with 3 other friends. There are 4 people sharing. The other cake, I'm sharing with 8 people. Okay, so 8 people are sharing a cake. So which one is going to give me more cake if I share it with 4 total people or if there are 8 total people? Well, my slice is going to be bigger if I'm only sharing with 3 other people. Therefore, 3/4 is greater than 3/8. I get more cake when I share with less people. Okay? The more people you share with, the smaller your piece is. Okay? Think about it this way. Remember, we talked about it in class with money. If your mom takes you to the toy store and gives you $20 to spend on a toy, you're going to get something awesome, right? If she takes you to the store with your 5 brothers and sisters and gives you $20 and says that you can each pick a toy, but you only get the same $20, your toy is going to be much smaller probably, and it's definitely going to cost less, right? Because if you have to share $20 with your siblings or you get that whole $20 to yourself, the piece is going to be smaller that belongs to you, okay? So now let's look at the next one, number 2. 5/6 blank 5/8. So I get 5 pieces either way. The numerator at the top is the same, but the denominator is different. So if I share with 6 people or if I share with 8 people, where is my piece going to be bigger? My piece is going to be bigger only sharing in the 6 chunks. So 5/6 is greater than 5/8. Remember, alligator mouth eats the big one. So the alligator mouth should be eating 5/6. Okay? Number 3, 1/3 blank 1/2. So would I rather have a pizza that I'm sharing with Mrs. Von Berg and Mrs. Winters? Or would I rather have a pizza that I'm just sharing with Mrs. Winters? Well, my piece is going to be bigger if I only share with Mrs. Winters. So 1/3 is less than 1/2. So the alligator mouth should be eating 1/2. Okay? If you had trouble with set D, please make a little mark on your paper, okay? And that way you can ask an adult or myself, a parent, someone at your house that is a adult that helps you with your homework, or even a big kid, maybe a big brother or big sister. That way you can ask someone for help once the video is done, okay? So if you are having trouble with that, you can make a notation. All right, and I am going to move on to our next page. Let's see. And our next page for set E, I'm actually going to start a separate video. That way it's not too long if you lose your place. So actually, I am going to stop this video right here and go ahead and flip the page and start the new video, and we will start on set E. All right, see you in a minute.